Hey guys, today we're going to solve LeetCode number 136, single number. So we're given an array of integers where every element appears twice except for one, and we need to find that one. And our algorithm should have a linear runtime complexity, and we should implement it without any extra memory. So the solution can be already seen right here. So essentially what we're doing is just looping through the whole array, and for every current element, XOR it with the current accumulated value, which is just the XOR of all the previous values. So yeah, I'm just going to submit it to show you that it works. But one cool thing about this is I want to show you a way to think about the XOR operation that will make understanding this really easy. So here we can see the truth table for the XOR operator, right? So one way that I want you to look this is if you have a 0, the XOR operator doesn't do anything. Like you can see, here we have a 0, so the digit remains the same. Here we have zeros, so nothing happens. Here we have a 0, so nothing happens, right? It's just the other digit. So 0, the result is other digit. Here we have a 0, the result is the other digit. But whenever we have a 1, you can view this as whenever you have a 1, the result is the opposite of the other bit. So for example, here we have a 1, the other bit is a 0, so the result is 1, because 0 negated is 1. Here we have a 1, or here we have a 1, and the result is just the other one negated, so it becomes a 0. And the same thing can be said here. We have a 1, here we have a 0, we negate this, and it becomes a 1. And the reason for which this is so helpful is because here, well, what I'm saying is if you have a 1 as an operator of the XOR, you are basically going to toggle the other bit to which you're comparing to, right? So since here we're doing the XOR between the accumulated value of all previous XORing and the current element, then what happens is that since every element appears twice except for one, like we're going to toggle every bit in our accumulated result twice. And toggling every bit twice is basically the same as not toggling any bit at all, right? So what that is going to do is we're going to XOR an accumulator twice for every element, and so that accumulator at the end of those XORs is going to be 0, and then we're going to XOR it with the element that is only appearing once. And actually here the order doesn't matter, right? It only matters the parity of the amount of times that a certain bit is flipped. So it doesn't matter that we flip it twice, maybe at the beginning and at the end. All that matters is that we flip it an even amount of times, and the digits, the bits in the element that only appears once, are flipped an odd amount of times. So in our result, we're going to have all and only the digits in the element that is appearing only once, because those are the only digits that are the only bits that are flipped an odd amount of times, and so they will be ones. All the other bits are going to be zeros because they are flipped an even amount of times. So that's it from me today. Thank you for watching, and bye.